Hello everyone, Dev Victoria is here. Welcome to another video about making of the Pinball Mansion. Uh, so basically I started to work on a new bumper behavior. So what I would like now to achieve that if these two bumpers are activated all together, then they would make the scores double. So if these two activated and someone hits, let's say, a drop target, the score for the drop target is going to be count as the double score. I I think I hope I explained it understandably. I'm not sure. But if these two on the dark side are activated, then it would halve the score of everything. So if these two activated, someone hits a drop target, then only the half of the drop target's score will be added to the total score. And I decided that I'm going to handle this total score modifier independently of the total score, because the total score is written frequently. Total score modifier should be calculated almost as frequently, and I don't really want anything to block each other. And also what I figured out that even though the same rules are going to be applied for activating the bumpers than to light them up, meaning if a ball hits a bumper, then it is going to be activated. And then if the ball hits this other bumper, that is going to deactivate this bumper. So the rule is quite similar to the rule of how the bumpers are lighting up, basically. But for now, I'm going to handle these two things differently. Maybe later, when I have more similar mechanism on this table, then I might refactor it. But for now, this is going to be a totally independent calculation from the light switching thing. And this is going to be a bit complicated because it is going to happen in several steps. So basically, since these two has to be activated both in order to make the score double. And there might be other score affecting things around the table. For now, there isn't, but later there might be. So I created a diagram, make it a bit more easy to follow what we are going to do. So we've got the score modifier part state data. This is explicitly, let's say, a bumper. So whether or not the bumper is active or not, obviously the entity has this component with this active field. So this is how this is supposed to be read. And the score modifier data, which is going to be on an entity, is going to have a modifier value, meaning if this is the 2 for the good bumpers, for example, half for the bad bumpers, and it is going to contain a dynamic buffer or score modifier parts, meaning the entities on which the score modifier parts are. So if all of these are active, then this modifier value should be calculated with. And also the score modifier data is going to contain as active field. This active field is going to be a calculated field, which is a bit of a cheating. As far as I know, when it comes to data-oriented design, you really have to make sure that your database is in, I don't know, the most available normal forms there is. I don't know how many, if maybe fifth normal form or something like that. But typically, those normal forms doesn't really contains calculated values, at least as far as I know, because you're supposed to calculate it. But in order to make this whole activation processing easier, I figured that I'm going to cheat with the design and I'm going to contain this calculated field here. So we are going to calculate this by getting all through this score modifier pass state datas, and if all of them are active, then this is going to be active too. If there is at least one who is not active, then this is not going to be active either. There will be a system which is calculate this field. This modifier value is given upfront design time, if you like. And once we've got all of these core modifier datas, then we can use this to calculate the total score modifier. Yet again, this is a calculated field. May or may not be ideal, but I think this is going to make life easier. And also, this is going to contain a dynamic buffer score modifier, which means we are going to contain all of the entities who's got the score modifier datas, if you like, in order to calculate this total score modifier. And there will be one more component we are going to refer. This is the switch score modifier part data. This is going to be used by the trigger to change this active field on specific entities. So this is going to be containing the score modifier entity, score modifier part entity, and the requested active state, meaning which way it should switch this active field. So the trigger processing system is going to use this component basically. So let's see, in light of this, what kind of stuff I set up in the editor. So let's pick one bumper that is right here. So it has a score modifier pass state data, meaning it stores whether or not it's active. And it has two score modifier pass switch data, that which bumper moving part should be turned off. This is the opposite bumper moving part. And which bumper moving part should be turned on when the collision happens. This is itself, obviously. And also I've got this bumper modifier up. This contains the bumper moving part of this bumper and the bumper moving part of this bumper, which is this one. So these are the good bumpers, and if both are active, then this field is going to be active too, and this modifier is has a value of 2, and this modifier value is going to be applied for the total modifier value. Similar, the down bumpers are the bumper 2 and the bumper 3, and yet again similar modifier value active. And then the scoring elements is now going to contain beside the total score data, a total score modifier data. This total score modifier actually should be 1 because initially this is 1, obviously. The score modifier object should be an array which contains the bumper modifier up and the bumper modifier down. This is what we are going to use to calculate the total score modifier. So this is the editor setup. Now let's see how this is created component-wise. The score modifier part state data is very simple, just a bool active field. The outdooring component can be generated automatically. The score modifier data outdooring is yet again straightforward. We only got an array of game object and we are going to convert it into an array of score modifier part that, or let's say a dynamic buffer of score modifier part which contains the entities with the score modifier part. So this is yet again not necessarily too complicated. The total score modifier data outdooring, same thing as before, a total score modifier and with a dynamic buffer of score modifier that are containing the score modifier entities. Okay, the score modifier part switch data outdooring. Yet again, I would like to allow the designers to put in multiple components of this type. So behind the scenes, we have to convert this into a dynamic buffer, similar as we have done with the light switching. So basically, we are checking if the entity already has a switch score modifier part data. If it has, then we just get the buffer. If it doesn't, then we add the buffer. And then we are going to add a new switch score modifier part data into that buffer, basically, with the score modifier part and the requested active field. I hope this is clearly understandable for you guys. And now let's see the systems. So now the first system that we are going to take a look at is the trigger score modifier part switch system. So this is going to be processing this switch score modifier part data which I have mentioned before. So it's just a trigger events job. It is going to get the ball tag, the switch score modifier part data and the score modifier part state data, and we are going to get the switch score modifier part data entity. These are obviously in a buffer, so we have to process the whole buffer here. And from the buffer, we are going to get a switch score modifier part data, and we check which score modifier part it is referring to. And once we got that, we are going to make sure that the active field is going to be same as the requested active. And then we are going to write back the new data in order to make sure that this is modified. This is going to be modified. So I hope you understand this, not that complicated, similar what we did with the lights. Okay, now the next system what is going to calculate this active field from the score modifier parts. So on the entity, we've got the score modifier as a component, and we've got the score modifier part as a buffer. So we need a component type handler and a buffer type handler for the calculation. And obviously we need the score modifier part state data in order to get whether or not the part's state is active or not active. And we just have to go through the score modifier part buffer, and basically in start we are going to set the modifier active true, and then later we are checking the specific part's state, if it's active or not, meaning we are going to apply a boolean and with the modifier active and this active field, and if it's false, this is going to make the modifier active false. If it's all of the cases true, then the modifier active is going to stay true. And then we just have to write back the score modifier data, get the score modifier data, and we just have to write back the active field with this modifier active value. This is yet again not necessarily that complicated. And the total score modification calculation system, this is what is going to be calculating the total score modifier. If a modifier data is active, then it's going to calculate with this modifier value. So how this is all working. So we have on an entity, we got the score modifier data. We need the score modifiers buffer and the score modifier data component data. And basically what we are going to do is processing this dynamic buffer of score modifiers. And in the beginning, the modifier value is 1. And then if the modifier data is active and the modifier value is larger than a threshold, in order to avoid zeroing out the total score, because this modifier value, because there could be a case where the player doesn't score anything at all, but I think that wouldn't be a too good mechanic, would it? So if it's larger than 0, basically we are going to multiply the modifier value with this score modifier data's modifier value. And then we are going to write back the total score modifier data into the total score data array. So yet again, not necessarily too complicated. And now one other thing has to be mentioned here. Since we are introduced this total score modifier data, now when we are calculating the score in the scoring handler system, we have to calculate even with this total score modifier data, meaning we have to multiply the score when hit with this total score modifier and add the resulting value to the total score, basically, because obviously this has to happen. So we need this total score modifier data in the scoring handler as well. And obviously all of this scoring system, the trigger scoring system now get this, and the collision scoring system now get this. So that is all cool and awesome. Now let's see how this all works when we are playing the game. Okay, now the game is running. Let's grab our test ball. So basically the score on a bumper is 100. Let's activate these two. Now the score is 200. But if let's say I'm going to hit a drop target. The drop target's normal value is 50, but now since the scores are doubling, now it is going to score 100. Let's hit another one, score 100. The rabbit score is 1000. Now because of the double score, it's 2000. Now let's switch off one of those bumpers. Now we are going to back to the normal scoring system. So this is now calculates 50. Let's activate the dark side, so to speak. Now the value for the drop target is going to be 25, and the rabbit, I think I managed to hit it 2 times. It is going to be half 2. And now the bumper is only scoring 50. And now if I hit a drop target, that is scoring 50. So I think the system is working. And the last thing I haven't talked about is this score multiplier display. This is going to be in another video, don't you worry. You are going to be informed how that is working. But for this video, this is what all I wanted to say. I hope you enjoyed it and perhaps learned something from it. And see you in the next one. Goodbye for now.